In this module, we will look at the A320 fuel system and compare it to the A330-200 equivalent. On the A320, the fuel is only stored in the wings and in the wing center box of the fuselage. There is no fuel tank in the trimmable horizontal stabilizer, THS, therefore no center of gravity, CG, control system. The fuel jettison system also does not exist on the A320. Like on the A330, the A320 has inner and outer tanks located in either wing. The A320 inner tanks are not divided into two parts, as on the A330. The inner tanks do not contain collector cells. Like on the A330, the A320 has a center CTR tank and a vent surge tank outboard of the outer tank in each wing. The total usable fuel quantity for the A320 is approximately 18,725 kilograms, calculated with a density of 0.785 kilograms per liter. Unlike the A330, the A320 has only 2 pumps per inner tank. There are no standby pumps. The inner tank pumps run during the entire flight. Note, the inner tanks are fitted with suction valves to allow engines to be fed by gravity if the inner tank pumps fail. Like the A330, the A320 center tank contains 2 pumps. But on the A320, each center tank pump is directly used for engine feeding. The left one normally feeds engine 1 and the right one engine 2. Note, the center tank pumps have no suction valves, therefore gravity feeding is not possible from the center tank. On the A320, the inner pumps are fitted with specific components. This ensures that when all pumps are running, the fuel is supplied from the center tank pumps preferentially, except for takeoff and landing when slats are extended. Some of the fuel supplied to each engine is used for the Integrated Drive Generator IDG oil cooling, when the oil temperature is high or at low engine power. During the oil cooling, through the IDG heat exchanger, the temperature of the fuel increases. This warm fuel then is normally recirculated to the outer fuel tanks via the fuel return valves. Like on the A330, the fuel flow to each engine can be stopped by using the corresponding engine low pressure LP valve controlled by the engine master switches and the engine fire push button switches. In each wing, 2 electrical transfer XFR valves allow fuel transfer from the outer to the inner tank. Note, only one valve is represented in our schematic. The fuel transfer from outer to inner tanks occurs automatically when the inner fuel tank content is reaching low level, about 750 kilograms. Note, when open, the valves are latched in open position and automatically close at the next refuel operation. On the A320, one cross-feed valve is fitted, allowing both engines to be fed from one side or one engine to be fed from both sides. A special fuel pump supplies fuel to the APU for startup when fuel feed pressure is low. It is not represented on this schematic. As for the engine, a low-pressure valve is fitted to cut off fuel supply to the APU. This schematic now represents the A320 fuel system. Let's briefly review the A320 specific components using the ECAM fuel page. The symbols and labels used on the A320 are similar to those on the A330, except for the outer to inner transfer valve indications and for the APU low pressure valve. You can see that all the components we talked about are displayed on the ECAM fuel page. The center tank in the wing center box, the inner tanks in the wings, the outer tanks in the wings, the inner tank pumps, the center tank pumps, the engine low pressure valves, the APU low pressure valve, the cross-feed valve. Let's now compare the two ECAM fuel pages. On the A320 ECAM fuel page, the total fuel used parameter is not displayed. On the A320, some label and symbol indications are different or have been moved, such as the fuel on board FOB indication, the APU indication, the APU low pressure valve indication, which is the same symbol as the engine low pressure valves, and the outer to inner transfer valves indications. Note, on both aircraft, the APU fuel pump is not represented on the ECAM fuel page. Here is the A330 fuel panel that you already know, and below, the A320 equivalent. Let's compare them. Like on the A330, each A320 inner tank pump has its associated push-button switch. Each center tank fuel pump is also controlled by its associated push-button switch. But on the A320, these push-button switches are used for the manual engine feeding control from the center tank. There is no center to inner transfer. Note, in manual mode, the center tank pump push-button switches must be selected off when the center tank is empty in order to avoid continued dry running of the pumps. The cross-feed push-button switch on the A330 fuel panel is also available on the A320 fuel panel. Notice that on the A320 there is no outer to inner manual transfer in backup. On the A320 there is no trim tank fitted, therefore there are no associated controls on the overhead panel. On the A320, there is no additional control panel fitted for inner tank split and jettison system. The A330 FCMCs are replaced on the A320 by one fuel quantity indication FQI system with 2 channels and one fuel level sensing control unit FLSCU. The FQI transmits the actual total fuel mass as well as the quantity and temperature of fuel in the tanks to the ECAM. Controls automatic refueling. The FLSCU is made of fuel level sensors in the tanks used for fuel levels measurement, high, low and overflow, and fuel temperature sensors to control the IDG cooling recirculation system.